Hi, my name is John, and I will be going over Chapter 4, Section 8, Complex Numbers. It's from Algebra 2, Common Core from Pearson. So, what is a complex number? It's pretty complicated, but we're going to try to dumb it down as much as we can, okay? Let's take a real simple example. What's the square root of 9? You say, well, we don't, if you don't know what it is, you just want to go, what times what? It has to be the same thing, has to equal 9, right? The radicand, which is the number in the inside. Well, what times that is 9? It's going to be 3. We're looking at just the positive portion of it, just for now, okay? So square root of 9 is equal to 3. Well, let's try another one. What's the square root of negative 9 then equal to? What times itself would equal negative 9? Well, if you think about this a little bit, there actually is no real number that will equal negative 9. Because any number times itself is always going to be positive 9, not negative. So what we do is we start going like this. Square root of negative 1 times 9. Is that fair? That's the same thing as square root of negative 9. We can break this up. Square root of negative 1 times the square root of 9. We know that the square root of 9 is 3. We know that square root of negative 1, by definition, is going to be called I for imaginary. I times root 3, we like to put our i's in the back. You have 3 i's. So there it is. This is called the imaginary number. It's not real. It doesn't belong on the real number line set. It's not that hard to get used to, but once you get used to it, it's a very simple process. So let's try another one. Let's try example 1, which is square root of negative 4. What is that equal to? Well, that's equal to square root of 4 times negative 1, which is equal to square root of 4 times square root of negative 1. Square root of 4 is 2. Square root of negative 1, by definition, is called I. You have 2 i's. Well, most people do anyways. Let's try a different one, a different example. What's the square root of negative 16? Well, the shortcut now is take the negative out to the outside, turns into an I. Okay, so that negative turns into a positive, turns into an I right there. And what's the square root of 16? It's 4. So you end up with 4i. There it is. Well, some people do have 4 i's. Most people have 2 i's. You can have 1 i if you want, but that's kind of hard on your body. So let's go on to the next problem. We want to figure out what I, by definition, is I. You want to find out what I squared is, I cubed is, I to the 4th, I to the 5th, I to the 6th. And you want to figure all those out. Well, I, by definition, is the square root of negative 1. You want to just square the left side and the right side. If you square the left side, you end up with I squared. Square and the square root cancel. These are inverse operation. You end up with negative 1. There it is right there. I cubed is the same thing as I times I squared, or I squared times I. I squared times I. Well, I squared is negative 1, because we just figured that out, times I is negative I. And then we want to figure out what I to the 4th is. Isn't that I squared times I squared is I to the 4th? I to the 4th is equal to negative 1 times negative 1. We just figured out what I squared was. Positive 1. And I to the 5th is equal to I times I to the 4th. Is that fair? I to the 4th times I is I to the 5th. We know that that's equal to I times I to the 4th. It's right here. It's 1. You end up with just I. I want you to do I to the 6th for me. See what you think you get. And then we'll go on from there. You'll notice a pattern. Once you notice a pattern, you can figure out what I to the 99th is. Okay. This kind of problem will come out on the SAT and the ACT as well, by the way, just to let you know. So let's try some other problems. Let's try square root of negative 18. Well, the negative comes out to the front, becomes I root 18. So what do we do this root 18? Well, we can simplify this radical. If you're not sure, you want to find the perfect square, which is 9 times 2. Isn't 9 times 2 18? So that becomes I times square root of 9 times the square root of 2. Square root of 9, we do know what that is. That is 3. You end up with 3I root 2. There's your final answer. Okay. Now we go into complex number. What is a complex number? Well, it's always going to be in its simplest state, a plus bi. That's the simplest state. And this is the real portion. This is the imaginary portion. This is what's called a complex number. So let's do a real simple problem. By the way, before we do something like that, let's actually see, let's do an example first. So I'm actually going to use the example from the book that they give you, or similar to it. Let's try example 3 plus 4i. So what happens is, this is the real portion, and this, not the I, but that 4 is the imaginary portion. So you end up with an axis. In the x-axis, you're going to have the real portion, and in the y-axis, you're going to have the imaginary portion. So you go with 3 in the real portion, 1, 2, 3, and you go up 4 in the imaginary portion, and there it is. So this would be 3 plus 4i. And then to find what's called the absolute value of that, by definition, the absolute value is the distance from 0 to that number, correct? So we want to find the absolute value of that, which is the distance from the origin to 3 plus 4i. You go 3 in the x direction, you go 4 in the y direction. We know that it's a triangle, and we also know that Pythagorean theorem holds. 3 squared plus 4 squared is equal to, you don't need the I at all. It's equal to c squared. 9 plus 16 is equal to c squared. 9 plus 16 is 25, is equal to c squared. So c equals 5. And there it is right there. You can actually do this on your calculator as well, just to let you know. So what I'm going to do is I'm going to turn it on. It's on, very good. And I'm going to go to math, which is right here. I'm going to go to the math numbers tab. You notice the default is on absolute value, press enter. And there it is right there. I'm going to say 3 plus 4. Your I is above your dot right there. So 3 plus 4i. And I'm going to take the absolute value of that, which is the distance from the origin to this number on the coordinate system. You end up with 5. There it is. You can barely see it. Okay, got it? 3 plus 4i. 3 in the x direction, 4 in the y direction. So, what is the formula for this? Absolute value of a plus bi is equal to, it's the Pythagorean theorem. C is equal to square root of that, right? So it's equal to the square root of a squared plus b squared. And that's where the Pythagorean theorem holds. Okay. So you can use the Pythagorean theorem if you want. You can graph it, see what they sometimes call it the modulus, by the way. See what the modulus, or the absolute value, the distance from the origin to that number is. Okay. So let's try to do a little bit more problems, and then we'll go to about 15-minute mark, and this is the phase 1. So Let's try another one. Negative 4, example number 3 from the book. 4 minus 3i plus negative 4 plus 3i. What do we get? So since we're adding, we don't have to put these parentheses anymore. Just could write 4 minus 3i minus 4. Distribute the plus and the minus 4. And then plus 3i. Here's the real component. Here's the real component. We just go 4 minus 4. That's the real component. Minus 3i plus 3i. That would be the imaginary component. Notice that? You end up with 0 there. You end up with 0 there. 0 plus 0 is 0. All that for nothing, guys. Let's try another one. Example number part B of this problem. 5 minus 3i. And then minus negative 2 plus 4i. You don't need the parentheses here since there's a positive right there. End it with 5 minus 3i. Distribute the negative, you get plus 2. Distribute the negative, you get minus 4i. The real component is here. 5 plus 2 is 7. The imaginary component, I'm going to use red pen. You have a minus 3i, minus 4i. What do you end up with? Give you a second. Minus 7i. That's the imaginary component. Okay? You should be able to do this by yourself. Let's do some more problems here. Let's do the products now. What I mean the product. Here's example number 4. You have 3i parentheses negative 5 plus 2i. So what we're going to do is we're going to distribute this out. 3i times negative 5 times negative 5 plus, right there, we're doing the second part, 3i times 2i. Let's do the first term. 3i times negative 5. We just multiply the negative 5 and the 3, the coefficients first. You end up with negative 15i. And then plus 3i times 2i is 3 times 2 is 6. I times I is I squared. But what is I squared? Previously, we said that I squared is equal to negative 1. So we just replace it with negative 1. So negative 1 times 6 is negative 6. And then negative 15i. We don't like this form because we like to put the real portion up in the front. So it's going to be negative 6 minus 15i. And this is in standard form. Let's do one more example problem, and then we'll stop. Okay. How do you do 2 minus 3i times 4 plus 5i? Well, we have to fold it out. First, 2 times 4 is 8. There it is. Your outer, 2 times 5i is 10i. Negative 3i times 4 is minus 12i. And negative 3i times negative 5i. 3 times 5 is 15 with a negative in front. There's a negative times a positive. Negative 15i squared. But what was I squared? That's equal to negative 1. So to get rid of it, just change the sign on that. That's a shortcut. So whenever you have an I squared, just change the sign. If it's negative, turn to positive. If it's positive, turn to negative. So it's going to be plus 15. So we do the real portion again. 8 plus 15 is going to be 23. And let's do the imaginary portion in blue. 10i minus 12i. You have how many i's? You have negative 2 i's. And that will be your solution of this problem. I'm going to check it with the calculator on both of them to make sure that it works. Let me bring out my calculator really quickly. You have, let's do this one first. 3i, second and above the dot, parentheses, -5. You have to use this negative right here. You cannot use this minus. -5 plus 2i. There it is. And then press enter. -6 minus 15i. Let's try the second problem. Parentheses 2 minus 3i. There it is. And parentheses times 4 plus 5i. And there it is. 23 minus 2i. 23 minus 2i. Perfect. Sometimes if it's not working, you get like a non-real answer, then you're in the wrong mood. So go to your mode right here. Make sure you're at the A plus BI mode right there. So that's my default. If you're at the real mode, and then let's try it again, square root of -9, and you end up with a non-real answer because it's non-real, it's an imaginary answer. So you can't really do that. So what you want to do is go back into your mode or your mood, the wrong mood. You can't get your answer right. So make sure you go to use the right arrow key, press enter. Now you're in the imaginary mood. Let's try it again. Second and the entry button. I like to use the entry button quite a bit. And then you end up with 3 eyes. Good luck with your homework for part 1.